All right, as usual, the very quick recap video plus one thing I forgot. How do you graph a derivative in your graphing calculator? Guys, it's very simple. You use the numerical derivative notation, but you put an X here instead of a number, and it will calculate it at every value of X that you want on your graph. So there, forgot about that. Realized when I was looking through my notes, didn't want to redo the video. There it is. How do you graph it? Boom. So what do you need to know? One, you need to know the circumstances under which a derivative fails to exist. We could have a corner. We could have a cusp. We could have a vertical tangent. And we could have a discontinuity. Those are the four possible times when functions can fail to exist. It is useful to be familiar with the functions. One reason we spent so much time in Algebra 2 talking and exploring and investigating all those different functions is so that when you see absolute value, you're like, I know what that one is. I know where the problems are. Two, what do I need to know? You need to know about local linearity. If a function is differentiable at a point, it is approximately linear near that point. Now, obviously, near is a judgment word. It's going to depend on the problem, but we'll talk about that more later on. And really what you want to be thinking about is if you've got a function that looks like it has a corner, does it really? You want to be careful about that. Numerical derivative in your calculator. You need to be able to know how to use your calculator. For our calculators, the TI-8384, it is Math 8. You should also know how to approximate a derivative using this, and the approximation is the function plus 0.001 minus the function minus 0.001, all divided by twice the 0.001. And you can just type that into your calculator given the value of A. You need to know how to be able to calculate. And then watch out for foolery. Again, you need to understand the derivative of absolute value of X around X equals 0. This will tell you that the derivative is 0, but of course we know better. So do not fall for the foolery. Differentiability implies continuity, but not the converse. And finally, the intermediate value theorem for derivatives basically says that if you have a derivative at one point and you have a derivative at another point and the function is differentiable throughout, f prime of x must take on all these values. As I've said in class, the chicken can't get from one side of the road to the other side of the road without walking through all the points of the road in between. It's the same for values of derivatives. But again, it has to be a differentiable function on this interval for this to apply. Obviously, absolute value of x doesn't apply. You can go from -1 to 1. Boom. But it's not differentiable because there's that point in between. All right, that's chapter 3.2. Thanks for sticking it out. We'll see you later with 3.3.